Hello students, welcome to chemistry class. In the previous class we have studied about the reactions involving the displacement of nitrogen. So let us see the flow chart of the reactions involving the displacement of nitrogen. So in that, when arene diazonium halides, that is Ar, N2 plus and X minus, so it reacts with the cuprous halides. For example, CuCl in the presence of HCl, or CuBr in the presence of HBr, or CuCN in the presence of potassium cyanide. So there is a replacement of the halogens and nitrogen, so it gives the product, that is aryl halides. So for example, let us take the reaction between the arene diazonium halides with the cuprous chloride. So the Cl is to be attached to the aryl group and nitrogen gas is to be eliminated as a byproduct, right? So this reaction is to be called as Sandmeyer's reaction. Sandmeyer's reaction. Next, this arene diazonium halides reacts with the hydrochloric acid in the presence of copper as a metal, or this copper acts as a catalyst, or so it reacts with the hydrogen bromide in the presence of copper, so it gives the aryl chlorides or aryl bromides, and the halogen is to be eliminated along with the copper, and this nitrogen gas is to be eliminated, so it gives, that is Cu plus X, right? So this reaction is to be called as Getterman reaction. And the next reaction, the reaction with the potassium iodide. So this aryl diazonium halides reacts with the potassium iodides. So the iodine is directly attached to the aryl group, so it gives Ari plus N2 gas plus KCl, potassium chloride is to be eliminated. That is, the reaction is the replacement of diazonium group by iodide ion. Next one, the reaction with the fluoroboric acid, that is HBF4 fluoroboric acid. So it reacts with the fluoroboric acid, so it gives Ar. So the final product is ARF, that is fluorine is to be attached to the aryl group and BF3 is to be eliminated, and nitrogen gas, that is diazonium group, is to be eliminated as nitrogen gas. So this reaction is the replacement of diazonium group by fluoride ion. Next reaction, that is replacement by hydrogen. That is, so the arene diazonium halides reacts with the hypophosphorus acid. That is, hypophosphorus acid is H3PO2. So it gives aryl hydrogen, that is hydrogen attached to the aryl group. Generally it is to be called as benzene group, plus diazonium group, that is N2 plus, so this H3PO2 on oxidation it is to be converted into H3PO3 plus hydrochloric acid is to be eliminated. That is, the reaction with the hypophosphorus acid, arenes are obtained and this hypophosphorus acid is oxidized to phosphorus acid. Next reaction with the ethanol, that is, so this aryl diazonium halides reacts with the ethanol, that is C2H5 and it is OH. ethanol. So it gives aryl plus hydrogen, that is hydrogen is to be attached to the aryl group, and this ethanol molecule is to be converted into aldehydes, that is CH3 CHO acetaldehyde, and this Cl that is X is Cl. So this X is to be combines with the hydrogen, so it is to be eliminated as HX. So here also hydrogen halide, that is HX is to be eliminated, right? Next reaction, that is the reaction with the water molecule. So this arene diazonium halides reacts with the water, that is on hydrolysis, so it gives AROH. So it is to be called as phenol. So phenol is to be produced and nitrogen gas is to be eliminated, and the byproduct, that is one more byproduct, is hydrochloric acid. And next, this arene diazonium halides reacts with the HBF4, that is fluoroboric acid, and sodium nitrite NaNO2 in the presence of copper. So it gives ArNO2, that is nitro group is to be attached to the aryl group, plus there is an elimination of diazonium as nitrogen gas, and the byproduct is, that is the one more byproduct is NaBF4. These are all the reactions involving the replacement of diazonium group. Let us see the reactions involving the retention of the diazonium group. And next, let us see the reactions involving the retention of the diazo group. That reactions are generally to be called as coupling reactions. That is, diazo group is to be retained along with the reacting molecule, that is aromatic ring. Such reactions are generally to be called as coupling reactions. That is, so coupling reactions are the reactions in which the azo product obtained have an extended conjugate system, having both the aromatic rings are joined through the N double bond N bond. That is, two aromatic rings are to be joined along with the or through the N double bond N bond. Such reactions are generally to be called as coupling reactions, and these compounds are often colored and are used as dyes. Let us see the example for the coupling reaction. That is, so the arene diazonium halides. For example, let us take benzene diazonium, benzene diazonium, that is N2 plus, and halide X minus. So it reacts with the phenol. It reacts with the phenol, that is double bonds, and it is OH. So the hydrogen present at the para position, that is para position to the hydroxyl group. So it reacts with the arene diazonium halides in the presence of base. For example, base is NaOH or potassium hydroxide. So the two aromatic rings are to be joined through the N double bond N bond. That is, two aromatic rings are joined through the N double bond N, and this X is to be eliminated along with the sodium. So it gives NaX, and hydroxyl group combines with the hydrogen, so it gives H2O molecules, and the remaining, that is aromatic ring and hydroxyl group, are to be attached to the diazo group, that is double bonds, and it is OH. So the two reactant molecules gets coupled through the N double bond N bond. So such reactions are generally to be called as coupling reactions. So this molecule is to be named as para-hydroxy that is at para position hydroxyl group is attached, so it is para hydroxy, and N double bond N group is to be called as azo, and it is benzene, para hydroxy azo benzene. Like that, let us see the reaction of benzene diazonium chloride with the aniline, that is arene diazonium halides so it is N2 plus and X minus, so it reacts with the aniline. So in the coupling reactions, the hydrogen present at the para positions or generally reacts with the diazonium group in the presence of base, so that is either sodium hydroxide or potassium hydroxide. So it gives, so this arene ring, so this arene ring along with diazo group, that is N double bond N and single bond, and it is double bonds and NH2 present at the para position, and the byproducts are, that is potassium chloride plus H2O molecules. So the obtained product is to be called as para amino azo, and it is benzene, para amino azo benzene. So the obtained product generally has yellow color, that is it is to be called as yellow dye, and in the previous reaction the obtained product has orange color, so this compound is to be called as, that is color of this compound is orange, that is orange dye. So these are the two chemical reactions involving the retention of the diazo group, that is to be called as coupling reactions. And next let us see the importance of diazonium salts in the synthesis of aromatic compounds. That is, the diazonium salts are very good intermediates for the introduction of fluorides, chlorides, bromides, iodides, cyanides, hydroxyl groups and NO2 groups into the aromatic rings. That is, we cannot directly attach these groups to the aromatic rings because the double bonds present in the benzene ring undergoes delocalization. That delocalization gives the extra stability for the benzene. So in order to introduce these type of groups, that is fluorides, chlorides, bromides, iodides, so we can easily attach this type of groups when the compound is diazonium salts, right? Next, the replacement of diazo group by other groups is helpful in preparing those substituted aromatic compounds which cannot be prepared by the direct substitution in the benzene ring. That is, those compounds which cannot be directly prepared from the benzene ring, that compounds are generally to be prepared from the diazonium salts by replacing the diazo groups. So these are the main importance or uses of the diazonium salts. So this is amines chapter. So very important chapter for the examinations as well as for the competitive exams.